Hello. Is everything working right now? Looks like it. I should be up. I got about 10 minutes here before we start, so I'm gonna get some other things going here. I'm just gonna mute myself. All right. Hey, people are starting to come in. I got a couple minutes still. I just shared this with you on the classroom as well. This is a chart that just has your conversions on it, so they're all in one place. And it goes like, here's your units of length in the US customary system, here's feet, yards, inches, stuff like that. Here's your units in the metric system. So this is between each system, and then this column here is system to system. So this is all length, this here would be weight, this is area, which we really didn't get into much, but it's done the same way. You just find the conversion ratio. Here's volume. This is temperature, and this is time, and this is fluid ounces between systems. So just a little tool, and at the bottom it gives you your metric prefixes. If you need your staircase still, if you like the staircase method, this is a little bigger than the one I gave you. But it's there for reference in case you need to know things. Look it up. I'm not going to ask you to convert with temperature, but it is a formula you just kind of plug in and solve. The fact that it's not an equal jump. A jump of 1 degree in Fahrenheit is not the same as 1 degree in Celsius. So that's, again, it's a reference tool. It's attached to the classroom, so you can go in the classroom and you can grab it from there. I attached it to this lesson. So you might need it. You might just use what's in the book. I'm not sure exactly what kind of questions I'm going to be asking in the future about it. I don't know if your book has all the conversion ratios to it, or you could just go on the internet and find something similar to it and use that. So again, that's attached, just another tool for you to reference, look at. If you have questions about it, feel free to ask or email. Either one. We are getting to the end here. Let's see, today we are converting between units. So today we are going from metric to empirical, or US, this is US system, US custom system. So it's going between the two of these. And again, it's done the same way. There's a conversion ratio to do it. That chart was, I just attached it to today's lesson. So if you go in the classroom, you can get it from there. I just attached it. I was looking for a good one. That's the best I found. I thought that one had the most information on it. And pretty easy and organized to read for you. But you can also use the charts in your book, or you can find your own on the internet. But again, those conversion factors, those conversion ratios are things you just look up. So I started off with this problem here, and I was wondering if you could figure this out on your own. So I'll give you a minute to look at this one. This is dealing with speed. I will tell you, if you look on page, your homework today is page 220, but your charts are on page 219. So on page 219, it is telling you that, let's get how it's actually written here. In a chart somewhere, it is telling you that 1 mile is equal to 1.61 kilometers. It actually says about. You're going to use this as your ratio. So this little squiggly equal sign means approximately. Maybe I didn't save it. I didn't save it. There, now it should be posted in like 3 seconds. Take a minute and look again. I just saved it, sorry. I was just adding it now. So again, I added a chart on the Google Classroom today just as a reference tool for you. There's no work involved with it. It's just a list of all the conversion factors that you'll have to find. And then I'm asking you to do number 1. Let's say your normal speed limit is 25 miles per hour. Maybe you go to Canada or something and they don't know what a mile is up there. They use kilometers. So what is the same speed in kilometers? And your book is giving you the conversion ratio that 1 mile is approximately 1.61 kilometers. And it's probably going to ask you to round this. Most of the time when you go between systems, you're going to round it. Yeah, we can look at that. Let's look at this one first, and then I'll get to questions on the homework. This is technically our little warm-up today. So hopefully you should be setting this up. It does give you this fraction. So our given thing is 25 miles per hour. Technically that's 1 hour, so this here is our given. We do have units in the bottom, but we also aren't going to touch our units in the bottom because we want our bottoms to be hours, and they already are hours. So we're just going to multiply this by our conversion ratio. And again, I want miles to cancel, so I'm going to put miles on the top. Follow those units. Keep the units straight here. If miles are on the bottom, then kilometers are on top. And the 1 goes with the miles, and the 1.61 goes with the kilometers. Now my miles will cancel, and I'm left with kilometers on top and hours on the bottom. And I just multiply. What's 25 times 1.26? You can go ahead and do that on a calculator if you want. 25 times 1.61, and that's giving me 40.25, and technically it's over 1, but again, when we simplify, we just ignore that, because 40.25 divided by 1 is just 40.25. So this is 40.25 kilometers per hour. So you might have speed limit signs more around 40 kilometers per hour on the roads in Canada versus the 25 miles per hour in the US. Just like that. And then Catherine was asking for number 14 from yesterday. I have to look it up. Number 14 from page, what was this, 216? Saying 216. Was that yesterday's or the day before? Or what? 216, that was 2 days ago. Oh, this is our gallon problem. So I'm going to paraphrase it for us. I'm going to pick out the important information, but you can read along in your book. It says a student is making punch for the baseball team by combining 5 quarts of 3 different types of juice. So we have 5 quarts of 3 different juices. How do you spell juice? A horrible speller. Juice of 3 different juices, and we want to know how many gallons this is. So it's going to ask for gallons. So we're going to go ahead and find that conversion ratio. Do we know how many quarts are in a gallon? You should know that it's given that 1 gallon is equal to 4 quarts. So this is the information we have, because that's plural. This is the information we have, and we want to solve. Now let's stop thinking about individual juices here and just think of how much liquid gets put in there. We have 5 quarts of 3 different juices. So that's 5 quarts of the first juice, that's 5 quarts of the second juice, that's 5 quarts of the third juice. So that's actually 15 quarts. 5 times 3 is a total of 15 quarts. So this here is our given information. I want to know how many gallons 15 quarts is. Again, we just did that through reasoning, but you could just did 5 times 3. Gives you 15 quarts. So I want to take 15 quarts, and I want to turn that into gallons. So I'm going to set it up. Again, I need quarts to cancel, and I need gallons on top. My conversion ratio is coming right from here, which is 1 gallon for 4 quarts. So we're going to solve this. You're going to get quarts to cancel. There's technically a 1 here. 1 times 15 is 15. 1 times 4 is 4. So it is 15/4 gallons. However, this gets reduced down to 15 divided by 4. You can leave this as a fraction. You can be like, how many times does 4 go into 15? And you can be, well, like there's 6 or 3 and 3/4 left. So you can do 3 3/4 gallons. This is an acceptable answer. Or you can take it as a decimal, which would be 3.75 gallons. So either one of these is acceptable. You go with the fraction, go with the decimal. I don't know if it asks specifically to round like the nearest tenth or something. No. So you can just do it like that. Are there any other questions about yesterday's work, the day before's yesterday's work? I mean, the procedure is no different for going from metric to empirical, or vice versa. That's why the yield's going both ways. You just multiply by conversion ratios. So again, these conversion ratios are probably just going to be uglier numbers because there's not a good relationship between each of the numbers here. So let's see if we can find one. So, is it what page is number 10 on, Catherine? From yesterday. I think for today it says round to the nearest hundredth. So yeah, you can round your answers because again, you're not going to get necessarily good ones. This is page 219. No, this was page something like 218 or something. 218. Number 10 says a dictionary has the mass of, so again, mass equals 585 kilograms. A math book has the mass. This is a dictionary. This is for the dictionary. You have a mass of 5. 625 grams. This is a math book. And it's asking greater mass. So which one's greater? And by how much? So which one's greater and by how much? So you're just comparing the two. So it's asking us, is 5.85 kilograms, you can think of the circle because you have like a greater than, less than, or equal to sign in there. 5625 grams. So you can set up either taking this to grams or taking grams to this, and it's really easy with the metric system because you're ending up just moving decimal points. I probably haven't if you turned them in late, Sarah. I'm getting to it, but then I had to do something else quick. So I know you turned in a whole bunch of stuff. I'm still working on updating grades. Hopefully by the end of the week I'm set. I'm trying to get 7th and 8th grade done first. Well, 8th grade really because they have less time than you guys. But we're working on it, so just be a little patient with me, please. But keep bugging me too. That'll motivate me to do it. What are we doing? So we're either converting this to kilograms or we're converting this to grams. So your choice, and then we can compare, but they need to be the same units. So let's go ahead and take the 5.85 kilograms and make it into grams. I need kilograms to cancel, and I need grams on top. So this way kilograms cancels. And if you look in your book, it should tell you that there are 1,000 grams in 1 kilogram. Because that is your conversion factor. And then when you multiply, you're multiplying by 1,000, so you're really just moving your decimal point. So this is going to be 5,850 grams over 1. And then there's no units on the bottom, so this equals 5,850 grams. So this is 5,850 grams. And then you compare this number to this number. Right, this goes with the kilogram side, this one's larger, so you're going to go with that. And then it asks you by how much, so then you just subtract the two to get your difference. So then you can come over to the side somewhere and do 5850 minus 5625 and get your answer there. And you should be getting something along the lines of 225 grams. If you did it in kilograms, it would be pretty much the same setup, only you're going to take this and make it kilograms, so then this would be, I mean, again, you're just going to move a decimal point, so if we did this in kilograms, we want 565 grams to become kilograms, so grams would cancel. Here you divide by the 1,000 as opposed to multiplying by the 1,000. That's going to cancel, and this is going to give you 5.625. So 5.625 kilograms, and then you can compare this one with this one. You're still going to get that this one is less, and then when you subtract it, you're just going to get 2.25 as opposed to 225. Yeah, that's fine. I don't care. I'm assuming by this point you know how to subtract numbers. I'm assuming you know how to multiply numbers. I'm assuming you know how to divide numbers. I'm assuming you know how to add numbers. Square roots might be a bit tricky still for some of you, and squaring things might be a bit tricky, but I'm more concerned about the setup of this, solving it, making sure you have the right units. So this is kilograms over here. Making sure you have the right units on things. All right. So again, it's really the same process for everything we're doing today as we did yesterday and the day before. I don't know if you want, as you're working on page 220 right now, if you are confused on what any of those are asking. So if there's any questions on page 220 as you go through it, throw it out. But I mean, it's really the same thing. So like for number 1, you have 31 centimeters over 1. You want centimeters to cancel, and you're taking it to inches. So then you go look up the conversion ratio, and there's 2.54 centimeters in 1 inch, and you get 31 over 2.54. Divide that out. So 31 divided by 2.54 gives you 12.2, and it is now, centimeters are gone, you're now in inches. And that makes sense, because if you remember your ruler should be 30 centimeters long. So you actually probably have that memorized. In your ruler, right, it's 12 inches on one side, and the other side is 30 centimeters. So you know that there's 30 centimeters and 12 inches. And this is a little more than 30 centimeters, a little more than 12 inches. So it makes sense. Just doing some reasoning for it. So as you're working on, if you have questions, ask me. I'll stay on for a bit longer. Tomorrow we're going to look at some word problems with it all. So it's going to be a little trickier because I'm going to give you conversion ratios within the word problem. So you're going to have to sit there and look at the word problems to get the conversion ratios out, realize what they are, and then do your whole dimensional analysis part. But you do get to do some kind of fun, crazy problems that way, and you'll see tomorrow. I don't think I unlocked it yet. Yeah, tomorrow we got you got 4 problems tomorrow. One of which has scientific notation, maybe 2. One that has scientific notation. Can we do 5? Yeah, we can do 5. Five is asking you, again, some of these might take multiple steps. I don't know if 5 is one of them. We want 5 meters, 2 feet. I guess it uses the word feet. to feet. So I want to take meters to feet. So looking over at your table, do we have something that goes from meters to feet? We don't, but we know that 1 meter is approximately 39.37 inches, and you should know that 12 inches is 1 foot. So these are the two conversion ratios that we're going to use. In this case, you're going to do 5 meters over 1. We don't have a denominator here. We want meters to cancel. So looking over here, what ratio has meters involved in it? This one here. So we're going to put 1 meter on the bottom and 39.37 inches on top. Next one, we want inches to cancel. So inches will go on the bottom. Over here, 12 is with inches, 1 is with feet. Double check your units. I got a meters on top. That's canceling with the meters on the bottom. I got inches on top, canceling with inches on the bottom. My last unit is feet. I want it in feet, so this should work. I'm going to multiply my numerators. 5 times 39.37 is something. 5 times 39.37 is, and then times 1 again is not going to change it. It's going to be 196.85. And then 1 times 1 times 12 is 12. My units on top is feet. My units on the bottom is nothing. I'm just going to divide this as a fraction. Just reduce it down. I'm just going to divide it out. So divide it by 12. And I am going to get 16.4. And then it's like 0.41666. And it asks you to round, so we're just going to round it to 16.4 feet. So there you are. What is scientific notation? Scientific notation were those numbers that are like 5 times 10 to the negative third or something. I'll explain it tomorrow. It's not hard. Again, you just kind of ignore the exponents and use the actual number. The pages are for a grade. I hope to get them in this weekend. But they are completion. It's like 2 points each. And yeah, if you finished, you can go. You're good. Spend some time on science. Hopefully by Monday I have all your science posted for the end of the year. I got it covered for 7th and 8th grade today, so hopefully I get yours up by Monday. But yeah, if you know what's going on, it's just practice today. Again, it's going to take some practice, and tomorrow it's going to be a little more confusing because we're taking it out of word problems. So get down the actual setup and math part right now so you understand that, and then tomorrow we'll focus on analyzing what's going on in word problems. And the reason I chose scientific notation to do some of them is so you don't actually care much about what the number is. You just kind of copy whatever the number actually is. So we follow the units, not the numbers here. So if you have more questions, go ahead and ask. Oh, can I do 6? Yeah, I can do 6 as well. 6 is asking 2 centimeters, 2 inches. So I start with 2 centimeters, and I want to go to inches. And again, looking on the page before, on page 219, it gives you your conversion ratios in that table. And somewhere in there, it's going to say that, which way does it give it to you? Look at it. Yeah, it tells you that 1 inch is approximately 2.54 centimeters. So this here's your conversion ratio for this. This is what you want to know. And that's going to take, excuse me, that's going to take you right from centimeters to inches. This relates centimeters and inches together. So that's the only one you're going to need here. So we're going to start with 2 centimeters because that's our given. Put it over 1 because we don't have a denominator here. It's just 2 centimeters. We're going to multiply that by something with centimeters on the bottom, so the centimeters cancel. And then we know inches will be on top. We know it's 1 inch in 2.45 centimeters. 2.54, sorry. 54 centimeters. Go ahead and solve. 2 times 1 is 2. Centimeters will cancel, leave you with inches on top. Bottom is going to be 2.54. That is a 2. Divide that out. This is in inches. Boy, I'm having trouble with the stylus today. This is inches, so we're going to divide that out. 2 divided by 2.54 gives us 0.7874, and I want you to round, I think, to the 100th. So that 7 is going to bump this 8 up to a 9, and slap on your units. Alright, for page 220, should we write the conversion factors next to the answer? No, you don't have to write the conversion factors next to the answer, just throw in the answer. Your conversion factors are all given to you, so go for it. Number 4. Number 4, Catherine, we're looking at... Whoa, I gotta stop pushing that button. 35 kilograms to pounds. And again, looking on page 219, it should give you something along those lines. Yeah, it tells you that 1 kilogram is about 2.2 pounds. So you're going to use this as your conversion ratio. And again, follow the units. That's your given. You want kilograms to cancel, so they go on the bottom. Pounds will go on top. Our conversion is 2.2 goes with pounds, and 1 goes with kilograms. So you do 35 times 2.2. Which gives you 77. 1 times 1 gives you 1. Kilograms are going to cancel, leave you with pounds. That reduces down to just 77 pounds. 15, I think, is a word problem. So yeah, that one's kind of the strange one. Describe any patterns you found that can help you use the chart to convert between units more quickly. You might have noticed something, I don't know. Again, I do it kind of differently than what the book does, so I kind of told you what you do. But if you notice in the table, so what the book is asking you to do is to say something about what you notice about those conversion factors. And you should know all of them are in some way a unit rate. So all of them have at least a 1 somewhere, depending on how you rate it. Like, for example, 1 inch is 2.54 centimeters. That's my squiggly lines. Right? This here is a 1, and you'll note that all of them have at least something with a 1. Over here we had 1 kilogram. So something like that is a pattern that you should notice. It makes your multiplication elsewhere easier. I mean, you could have easily had, hey, I know that 2 kilograms is equal to 4.4 pounds, right? Because it is a fraction here, right? 1 kilogram over 2.2 pounds. I can multiply this by 2 and multiply this by 2, and I can get 2 kilograms over 4.4 pounds, right? So this is technically, you could have used this as well if I plugged into that. It's just easier if it has a 1, so you don't have to get a denominator and reduce it. I mean, I can show you that real quick. Like if I use this as a 4.4, and this was a 2, 35 times 4.4, 35 times 4.4 gives me 154, and then I divide that by 2, which gives me my 77, hopefully. Yeah. So, I mean, having it as a unit rate just saves some work, and it's nicer. You can say something along that for 15. I'm really not too concerned about 15. But #16 asks something else. And this one's, yeah, can you convert any custom unit to metric unit? So, can you convert any empirical unit or US unit, I don't know why I'm calling it empirical units today, to metric units? And Catherine, the answer is no, you can't. And I'll show you. All right, if I asked you to take, I don't know, 3 kilograms and tell me how many miles that is, right? Kilograms and miles don't measure the same quantity. So your measurements have to measure the same quality, right? This measures mass and this measures length. You can't convert mass to length. They are measuring 2 different things. You can't convert volume, like capacity, to time. Like it just doesn't make sense. Like how many is like 5 liters of water is how many seconds, right? It doesn't make sense. So you have to convert things with the same quality. And as long as they're measuring the same quality, yeah, you can convert them. Like you can convert meters to miles because they both measure length. You can convert kilograms to pounds because they both measure mass. You can convert liters to cubic centimeters because they both, well, those are both unit metric. You can convert liters to cubic inches because they both measure volume. Things like that. What was this? 7. And Evie, again, you don't need to write the conversion factors. It's fine. 7, you're taking 20 pounds to kilograms. So here you start with 20 pounds, and you want pounds to cancel. Now I'm going to go and look for some kind of relationship between pounds and kilograms, which I think was 2.2. Yeah, it says 1 kilogram is about 2.2 pounds. And I'm getting that from page 219. So look at the page before. It has the chart on the top. Get it from there. So that's 1 kilogram, or I'm sorry, pounds are on the bottom. That is 2.2 pounds per 1 kilogram. And in this case, you're going to be doing the division. So it's 20 over 2.2. Pounds will cancel and leave you with kilograms. So my unit is kilograms. So just reduce that down, which is 20 divided by 2.2 gives you 9.090909, so on and so forth. If you want to round it to 12.09, or I'm sorry, 9.09, go right ahead. If you want to do it to 9.1, I don't really care. If you want to put that, I don't really care, as long as you're getting in the ballpark. And that is kilograms. Then write the pattern I mentioned. Write that they are all the conversion ratios are unit rates. Just write that word for word. Again, the book has you doing it a different way, and you might see patterns better that way. But the bottom line is that dimensional analysis is going to work for every single case. I mean, you should notice that yesterday's lesson and the day before's lesson, it's really the same thing. It's the same process. You're still canceling units, following your units. It's going to work every time, and that's why it's a more robust tool. It's something that you should know, especially when you get into higher levels of chemistry. In particular, you're probably going to have a whole lesson on dimensional analysis on how to do it. And if you learn it now, which is really simple, it'll be easier to apply to the harder numbers. And tomorrow it's going to be a little bit more difficult just because the measurements that I'm giving you are going to be kind of strange. Like I'm going to be giving you different rates, dealing with different things, and the conversion ratios are going to be in the problem, and you're going to have to pull them out. But again, once you get the hang of it, it's not really difficult at all. It just takes time to set up, be neat, make sure you don't lose your units anywhere. Put your units down, write things down, keep track of things. So, any other questions? Last call for questions here. If not, I am going to let you go, and I will talk to you guys tomorrow. If you have questions before then, shoot me an email. I will try to get back to you. And yeah, we'll just end it there. So thank you for tuning in.